So today's, as we said, trigonometry. When we introduce the trigonometry to the children, okay, it is better we give a lot of insights to them before we touch upon the actual concepts of the trigonometry, the development of the trigonometry in the history, okay, and where all these things are used in day-to-day lives, okay, in real life, in real world. And it is also better to start with a discussion in our class, like uh, uh, the drawing. It's first of all, these are all using in surveying, mapping, isn't it? And astronomically, a lot of importance we have, okay, and finding the range of artillery, and a lot of fields are there. So let us discuss with our children just in beginning of the class how efficient it will be to creating a scale where the drawings of the large buildings are made, where we will get where we will went wrong in those kind of mappings. In fact, the trigonometry developed from such a need to compute the angles and the distances during the map. You people know that Hipparchus, the great astronomer, is the father of modern trigonometry, known as the father of modern trigonometry, developed these ideas out of these needs only. How can we see the map in a small map? How can we enlarge it and see the distances and the height? So these are all the discussions we can actually do in our classes. Actually, children will find a lot of interesting ideas to us also. Through the other children also will get benefited out of it. Again, we can also say like our own Indian mathematician Aryabhatta is the man who invented, or the man who developed the sine function, the cosine function. The name was earlier, it was, it's all mentioned in our textbook itself. Let us go through all those ideas once, so that they will get some insight to the an interest. Of course, when we say all these things, they will automatically develop some interest on this one. And again, we can talk about like different types of trigonometry exists, like core trigonometry. In core trigonometry, basically the triangles where 90-degree angles are involved, and the heights and distances. What we are learning is core trigonometry only, and to solve the heights and the distances. And again, we have plane trigonometry, okay, where more than the three words is triangles, but 90-degree angle is not compulsory in that one, that kind of triangles. Even if you have, how can we make use, how can we find the one angle and one side is not, how can we find out the third side? So these kind of ideas are used mostly by engineers, mechanical engineers and the physicists, okay, and these talks we can bring in our class. So, and in again, spherical trigonometry is another branch, okay, where the longitude and latitude ideas are developed, where a triangle is inscribed in a sphere, and how they can connect the angle and the sides. So these are all interesting fields. When we talk about these things, we can also touch upon the careers involved in this one. So when we talk about, okay, physicists, when engineers, mechanical, we can give them interest to these career options also. There are a lot of opportunities we are getting to touch upon. As teachers, it is our responsibility to talk about the fields where these are involved. So we are learning only the concepts here, small concepts, but the future of when they are learning all these things, how can we bring those ideas in their knowledge? We can at least give some insight to those things. So here is the how the development of trigonometry, okay. And in fact, mostly all the nature's shapes we can relate it to the right triangle, okay. That is why the importance of the Pythagoras theorem is so famous and so important, because in nature, if we touch upon any of the shapes, we can relate somehow, we can draw a small right triangle in that one, and the unknown measurements we can connect and find out that one. That is the importance. Similarly, one more is there, which is developed by the Greek mathematicians, okay, And here I'm just giving you an insight to this one. So this is a pyramid, okay, the greatest pyramid in Greek. So here the people started thinking while they build this pyramid and they go up and up. This one actually they took 20 years. That's what history says, 20 years to make this pyramid. So they started thinking, it seems like how can they climb up easily? So which slanting height will be more easier, which way they have to go up. So whether the sideways they have to go, whether that vertical corner wise they have to go up. All these ideas they started thinking, and we know that everything out of necessity only is developed in our world. Okay, so this is the need, it was actually happened. And moreover, the earlier the units were called as cubits. Okay, so they started, as I said, now whether which way they have to climb up, they started thinking. Okay, this was one of the need. Okay, and again as I said earlier, pyramid also we can construct a lot of right triangles inside this one. The Pythagoras theorem is one useful tool. Then two sides are known, how we can find out the third side. Whereas the trigonometry, the angle, if one angle and one side is not, how will you find out the other dimensions? So that was the thought for the development of the trigonometry. Okay, so here pyramid also we can relate it to part by part. If you split it, we can draw many right triangles in this one, and we can find out the side slanting height and all we can find out. So the first person who asked about the height of the pyramid is the Thales. Okay, which is the important theorem he developed, teachers, which is very important theorem, the Greek mathematician Thales contribution, which we are learning.
Basic proportionality theorem.
Very good, basic proportionality theorem. Yes, isn't it? And so he is the person who asked the people like how can we find out the height of the Great Pyramid. So he asked, it seems, what is the height of the Great Pyramid? And the people refused to answer. Okay, so he himself started thinking, okay, I have to find out the height. Even if they don't say, I need to find out the height. How can I estimate? So it's purely out of necessity that he developed the idea, and he considered that the sun rays are parallel. Okay, and if so, the similarity of two triangles can be used. Okay, similarity criterions, what we are learning today is his contribution only. So he considered the big one pyramid to a small similar triangle concept. Okay, and that helped him to understand the sides are proportional. That idea helped him to find out the height of the pyramid. So when we talk about all these things itself, okay, we can actually brush up the ideas what they have learned in the chapter trigonometry. Okay, the triangles are similar means, their sides are proportional. We are getting one chance, one more time to brush up all these ideas. Okay, so in that way we can bring those ideas. So this similarity idea is very important before we start the session of trigonometry, because most of the identities we are proving using this one. Okay, and of course we can talk about the father of modern trigonometry, etc. So here similar triangles, once we introduce these topics to the children, okay, we can always talk, of course, when we talk about the right triangle, it is very important based on one particular angle, the adjacent side, the opposite side, the hypotenuse, all these we needed to brush up a lot. Children do make mistake in finding that hypotenuse. I have seen children writing the, how do they understand that the smallest one can be the hypotenuse? I don't know. Sometimes they make that kind of mistake. So we can tell them the side opposite to 90-degree angle, it will be the largest one. All these ideas we have to brush up every time when we talk about a particular concept. Related concepts we have to brush up. See, we are now keeping in our mind not the bright students, okay, an average student or the below average student, how they will take up all these activities. Bright students, we don't even have to say anything. By reading itself textbook, they will understand. Okay, they will bring a lot of questions to us and all. So here we are trying to help our the children who is really in need of our help. So from here, we can actually, which is the opposite side, we can say, we can actually start with the similarity criterion, and then the sides are proportional. From this, let us, based on the angle theta, which is the opposite side, which is the hypotenuse, and all these ideas we can bring and relate. And then you introduce, this can be called as the sine theta. Sine theta, this ratio is called sine theta. We can introduce to them. Okay, the opposite side divided by the hypotenuse is the idea, sine theta. And of course, when we talk about the sine theta, cos theta, tan theta and all, we needed to first initially say SINE, sine, that is actual word. Then cosine it is, that is, these are all the abbreviations. Okay, tangent, so this tan is the abbreviation of that. Secant, sec we call for secant, that full name, with the full name itself we have to introduce the concepts to them, and then we can bring slowly. And of course, this we needed to stress upon the point that here it is not sine into theta. This is a notation, sine and one angle together we are writing. Sine of, we don't call that off there. Okay, so sine theta, when we say that it's a sine of a particular angle, which angle is mentioned there, based on which angle the opposite side, based on which angle it is adjacent side, that we are telling. That way you can tell these ideas to the children. And when we talk about theta point of view, I think at that time itself, based on the 90 minus theta point of view also we can bring the ratios. So when we write both the ratios at the same time on the board, okay, they can compare those ideas, they can compare those ratios, and immediately they will be able to identify that, okay, sine 90 minus theta, this ratio AB by AC equal to DE by DF is same as the cos theta when we consider the theta as our angle. So in that way, we can actually bring the idea of complementary angles here itself. Because when one angle of right triangle is 90, another one is called as theta, the third one will be definitely 90 minus theta. These ideas and all, they already know, children already know. So with this name only, the word cosine also has come. Cosine, cosine, complementary angle of the sine. In that way only, the naming itself is there. So when we talk about these things, they will not forget, okay, sine theta, the co-function is cos theta, cos theta, the co-function is sine theta. In that way, they will understand that one. So whenever we have the cosecant, CO, similarly, cotangent, that co means the complementary of the other function. In that way, we can express our ideas, I feel. And of course, the last one, when we are saying here, opposite divided by, sorry, I have made a mistake here in writing, opposite by adjacent here. I'm sorry for that, which we have to say, I made a mistake in copying, I think, right? 1 second. Yeah. Yeah, I'm sorry for that. I will sending it to you. I will correct it. Okay, I'll correct it later. So here in that way, we have to opposite by adjacent is the tan. In that way, we have to bring that idea. So when they look at both, they will understand that tan 90 minus theta is a reciprocal of tan theta. So we give a new name to that one. Cot is the name. In that way, we can bring. So in this way, once we bring all our basic 3 trigonometric functions, sine, cos, and tan, the other 3 we can introduce. Okay, other 3 we have to talk about the reciprocals. We needed to say cosecant is hypotenuse divided by. So once we clear picture of these 3, then the other 3 will not be that difficult to remember or to recollect and all. I feel so. And hence, after bringing this one, once again, I would suggest to you, this is to stress upon the point, which is the hypotenuse, which is the adjacent side. All these things we needed to say one more time, because children always makes mistake in this one, based on which angle is adjacent side is to be taken, which based on a particular angle, which is the opposite side is to be taken. They always make such mistakes. So give a lot of examples. You can even give you can make triangles in a sheet of paper like a worksheets, okay, and give names A B C D D E F triangle names, and give the worksheets to the children and do it as an exercise in the class and tell them to identify based on D, which is the opposite, based on D, which is the adjacent side. Like that, a good exercise is needed there, okay, so that the children will never make any mistake on those points. Then once again, talk about repeatedly when we are telling, definitely the idea will be registering in their minds uh, very well. Okay, and of course we are talking about all these things for an acute angle A in class 10 and all. We are learning about the acute angles. The angle will never be beyond 90. The A or B, whatever angle we are taking, it will be between 0 and 90 only. So higher angles are all, when they come to the 11th and 12th, they will understand, they will learn there. So, but the such angles exist, at least you can mention to the children here. Now here below, I am giving you some slides here, and this is an exercise to the children. And for each of the slide, we needed to ask what is given in the question, okay? What we have to find out, what ratio is needed. This is again an exercise to the children, okay? And how can we write an equation connecting this one? So based on case study type questions only, you can create your own problems like this one, okay? And here you can ask, okay, the angle is mentioned, okay, the person zip line, one man is coming down, that length is given. How will you find out the height from where the man actually started? These kind of ideas you can introduce to the children. While introducing them, do not always give the 30-degree, 45-degree, 60-degree standard angles alone. You can introduce to them any angle of that type. I will suggest that only, because children must know other than the 30, 60, 90 also, there are a lot of values which we are dealing with in the real life situations. Let them know about that one. These kind of angles also you use in the discussions. Okay, and then you ask them, okay, which trigonometric ratio is helpful here? Opposite side you have to find out. Hypotenuse is there. Okay, so how will you write that equation? So children will definitely ask how to find the sine 25.07. How will we find out that one? You can talk to them like, okay, there exists a trigonometrical table like a Clark's table or the logarithm table. It is available, and you can also introduce those things to the children. Okay, values we can find out. Okay, so these are all some new ideas to the children. Actually, when they learn trigonometry, a lot of new ideas they are learning. It's because this is one very important branch of mathematics, which is a stepping stone to the different fields like a calculus and other branches, other engineering mathematics. So this is very important. That is why this is considered as very important topic. So let us not introduce only the round figured angles alone. Okay, and similarly you change the question. Okay, you change the question, the opposite side is given, angle is this one, and how will you find out the hypotenuse? How will you write this equation? How will you connect this one with the angle? Which trigonometric ratio you are using here? Okay, these are all repeatedly asked these questions to the children so that they will form themselves. Okay, sine of this angle 34 will give you opposite side divided by hypotenuse. Let those concepts be make us thorough in their mind. Whenever they are asked something, by seeing immediately the diagram, they will be able to tell all these things. To that extent, they should be thorough. Again, create your own problem. So here is opposite side is given, hypotenuse is given. They have to find the theta, the angle. This is an introduction to actually inverse trigonometry. Okay, the value sides are given, but how will you find out the angle? This is the introduction to the inverse trigonometry, which in detail they are studying in the higher classes. Okay, so for that also table values will help us. Here at least you don't have to concentrate on how will you solve the problem, but our aim here is to make this equation. Are they writing this equation perfectly? That only we are aiming here. Sine means opposite by hypotenuse. Are they writing here? Calculation is not what is important at this stage. Okay, so that's what I am feeling. Similarly, bring a lot of these kind of questions in front of the students. so that a good discussion will happen in our classes. Classes will be interesting also. They will also find out a lot of triangles, right triangle shapes in the nature, and they will also bring some questions. Let them ask to create questions also. Their creativity will also develop by creating the questions. They will never forget. Okay, so here the cause is the idea. Like previous slides, here also we needed to keep on asking what we have to find out, which length we have to find out, what is the angle given, which trigonometric ratio will connect, write the equation of that one. So in this way, all these ideas we needed to tell the children. Okay, so here finally how to find the angle. So I'm just moving to the next because it's a kind of repetition only. Similarly, one more. So more than I have here given a lot of examples in that way. So here is the introduction of the tan idea, opposite side and the adjacent connection. So the children will write all these ideas. So let us help them to form the equations, connection only. Okay. And here now we are calling these sine, cosine, tangent as ratios. We don't use any centimeter, meters, like a units we are not using while writing these values. They are ratios. So why they are called ratios? Okay, we have to give them an insight. For that, different tools you can adopt. You can as I said earlier, give them lot of triangles in a sheet of paper, ask them to identify which are the similar triangles. From that, you same angle, give some triangles with the same angles also. Ask them to measure using their scale and the protractor and to come up with those ratios, come up with the sine ratio, cosine ratio, tan ratio. Okay, and let themselves verify whether the ratios are changing or not. Okay, so this is one tool, GeoGebra tool. You will get a lot of already created applets are available in the GeoGebra website. You can go through that. So some of the applets which we can make use here is this one. Okay, here angle is 40, we have kept here. Okay, if these are the sides, opposite side is given, adjacent side is given, sine value 4.22 divided by 6.557, the value is equal to 0.64. So when even if I change the side of this triangle, so different triangles, instead of drawing that on the board, probably you can create or show this to them. Okay, and you can tell them to write as an exercise. Okay, for this side length, what is the ratio? See, they can understand here the ratio is not changing when for the angle 40. How much ever you change the side of the angle, for all this one, the value of sine 40 remains the same. So those ideas you can bring here. So now change the angle and see what will happen. If you give different angle and you change the different sides, then what is happening here? So a lot of discussion is possible in the classrooms with these ideas. So one known value also I'm keeping here, for example, 45. If it is 45, we know that tan 45 value is 1, sine 45, cos 45 value is same, we know. So all these ideas you can bring into the discussions. Okay, with this kind of additional tools. Actually, even if you are not able to give them in the direct classrooms, you can at least give them idea. Okay, you can go home and explore these things, we can tell them. Okay, they will also learn with this one. So you when you get a time, try to create these kind of applets for your children. When you save this as a and keep it in the GeoGebra, they can go home and refer that one in your name itself. If you keep it, they can go home from the GeoGebra website itself, they can take it and see. So your duty also is to create these kind of applets. Okay, and so this is one tool which will help us. Sorry. So in that way, our aim is to say that these are all ratios and the value of a particular angle never changes, even if the sides are changing. Sides of the triangles are changing. That is why these are all called ratios. Those ideas you can bring in your classrooms. Okay.
Excuse me, ma'am.
Yeah.
You would be helping ma'am regarding this in this GeoGebra session.
Yeah, we will try to touch upon this now.
Yeah, thank you.
Yeah, how to create different applets we will touch up. Okay. Yeah, I have just I have kept in my mind what are all the topics I'll take. I have not decided yet. I will see that now.
Okay. I think this must be helpful to us also, ma'am.
Yes. Okay.
Like
Yeah, the already ready-made applets are also available. If you type the name in that resources, that is space provided there, a particular topic you type, in a lot of applets will come. In that one, you can select one and keep it in your favorites place. So anytime you can open it and see. Okay, you can also create.
Templates are available.
It's available, already available.
Thank
Okay. And the idea is like we needed to we also have to explore a lot with this one. This is the GeoGebra is just a tool only. How any other calculator is used the same way only it is. So we needed to bring in sit and think and bring in the ideas. How can we create this kind of applets and all? Okay, so again, then comes the specific angles, as I mentioned earlier. Now you can introduce the 30, 60, 90, 0, all these specific angles that only concentrating in class 10. Okay, when they go higher classes only, other values comes. So now they can, one very important idea I want to say here is when they come to class 11, here and all they will do. Class 10, if they ask you sine 30, immediately they will say the answer 1 by 2. Cos 60 value they will say. But when after a break, I think summer holidays or something, class 11, when they come, when we ask the what is the value of that, they will say, I don't remember, we forgot it. Okay. And once I saw one child writing in the examination hall. Okay, when he got the answer paper, immediately he started writing the table of values. 30, 60, 90. But then I asked, why are you writing this before you get a question paper itself? Then he's telling like, I will not forget if I write. Before I forget something, I want to write it in my paper. That's the answer he gave. So we needed to teach the children, even if they forget the value of tables, table values, how can they bring those values in any formula for that matter? While teaching any formula, how it is derived when we are explaining in our classes, they themselves immediately they can write down in your work in their working column and bring those values. So in that way we will concentrate our teaching. So this is how I will introduce these values in my system, and I have told them not to by heart the table. At least this image only they have to keep in their mind. They have to consider an isosceles isosceles triangle. Sorry, here it is an equilateral triangle with each side 2 units. Okay, and they know that in an equilateral triangle all the angles are 60, and they also know the in an equilateral triangle median and the angle bisector both are same. AD itself, you can also repeat those concepts one more time. They will not forget if you do that. So see, while introducing one concept itself, we are getting chances to talk about other concepts also. Let us make use. Do not jump into the new one. Let us spend time for the old one also. So here angle bisector, in this itself we are getting the 30, 60. So one side is 2 units. Since D is the bisector of BC, BD length and DC length are same 1 unit here. And using Pythagoras theorem, we can find out AD. AD will be root of 4 minus 1 here, 2 square minus 1 square. So root 3. In that way, AD length will be root 3. And from this, if they remember this diagram, then sine 30, immediately they can say opposite 1 and hypotenuse 2. They can immediately say that. Sine 60, what is the value? Sine 60 is equal to root 3 divided by 2. In that way, all this sine 30, cos 30, tan 30, sine 60, cos 60, tan 60 values, they can immediately get from this one. Once they know sine and cos itself, they can write the tan, isn't it? These two angle set itself, if they know, they will be able to write the tan also, and any other trigonometric values as well, because they know already that they are the reciprocals to them. So in that way only we are introducing here. And again, for the 45-degree angle, I do consider the isosceles right triangle to determine the 45-degree angles. Isosceles means we know that the base angles are equal. And so one unit is the side length is taken. Hypotenuse will be root of 1 square plus 1 square. Okay. And in that way, 45 means 1 by root 2 immediately. If they remember this diagram, immediately they will be able to. So this visual idea only we have to give them instead of telling them to by heart the table. I feel this is better, okay, in my experience. So here as we said, the table, okay, once we give this triangles, we can allow them to write, fill up these tables and all. Okay, we have various methods, tell them to make chart paper. We can tell them to write and keep somewhere so that they will see frequently, they will see that and learn these values. Okay, and all these ideas, suggestions we can give to our children. So I'm just coming to the idea of the trigonometric identities. Okay. Here the identities, we all know how to give the proof and all in our class. So I don't think we need a specific detailed method and all. Here I use the idea of the unit circle. Okay, where the OP radius is 1 unit. And the point PXY, while marking a point on the circle, the horizontal distance OA is the X and the vertical distance is always the Y. So this point we can also write, 1 second. So here, what I'm trying to tell is here, this X we can replace with cos theta, and this Y we can replace with sin theta. That is always this horizontal distance is the cosine value because adjacent X divided by 1. Okay, opposite Y divided by 1. So any point on the circle will be represented as cos theta, sin theta if it is a unit circle. So you keep moving this point to P on this circle. We are learning here only up to 0 to 90. Okay, the P now at present in class 10, it will move only up to 0 to 90. Okay, so you keep this P anywhere here. That angle value, that angle will change here when the P is moving. Okay, and the particular X value, X coordinate will give you the value of cos of that angle. Y coordinate will give you the sine of those angle, that particular angle. In that way, you can bring some insight to this particular diagram. And then from this one, you can talk about the Pythagoras theorem. So x square plus y square is equal to 1 here. And then slowly we can ask them to write sine theta value is y, cos theta is x. Pythagoras theorem helps us to write the value sine square theta plus cos square theta is equal to 1. In this way, we can talk about the identity. Similarly, other identities also we can bring into the picture. And definitely we need to ask them why it is called identity. Okay, why this is not an equation? Why we are not calling sine square theta plus cos square theta is equal to 1? Equal to symbol is there. It's why it is not an equation. So these kind of small ideas we can discuss in our classes so that it is true all the time. It is true for all the value of theta. That is why we call this as an identity, like any other identities in algebra. Okay, it is true always. So all these ideas we can discuss in our classrooms. Okay, and again, I'm just touching upon a few techniques which we can introduce in our classes. Once we discuss all these ideas which we have given, values we have given, the relationship between tan, cot we have expressed, each of the sine, cos, how they are related, what the ratio is, everything once we have discussed, then we can discuss about the super hexagon. This is one concept strengthening idea only. Okay, let me take one page here. 1 second. Okay, so once we discuss here, the super hexagon is like this. When we talk about the hexagon, we can ask them to write this, draw the hexagon in their class notebook. How they will write? Because the tan is related as a sine divided by cos. So you will start with the tan here, and then you will write the sine in this place, cos in this place, okay? And opposite to tan, you will write cot, okay? And all the C functions should come in the right side. So you write the cosecant here and the sec you will write here. Okay, once we write this one, all our trigonometric formula or the relationship you can bring from this one hexagon itself. Okay, how will we do this? So first thing, clockwise, let us take this clockwise. So clockwise, if you take this one, always the first one will be is equal to the second one divided by third one. In this way, that ratio will be true here. For example, tan theta will be is equal to, in that way only we formed this one. And in fact, sin theta divided by cos theta. Let us take the next three here. So next three, if you take sin theta will be is equal to cos theta divided by cot theta. So they will ask you how this is equal. So you tell them to prove that. So cos theta divided by cos theta by sin theta, is it equal to sin? Yes, they will identify it is equal to sin theta. In that way, here these three, if you are taking cos theta will be equal to cot divided by cosecant. Any three in this clockwise order, if you take, this idea will be true. These are all some activities only to just to make the concept clear to them. Okay, 1 or 2 classes if we spend these, they will also become confident. Okay, and similarly, suppose they forgot, okay, what happened if I take a clockwise, anti-clockwise direction, then also the result is true here. That is why we call this as a super hexagon. Okay, so for example, you are taking here secant, tan and sine. Secant is equal to tan divided by sine. Does it work? Yes, it is working. Sine theta by cos theta divided by sine theta. Yes, it is working. 1 by cos is equal to secant. Yes. So these are all the activities. Repeatedly, we are saying the same concept only. We are repeatedly telling them so that the ideas are clear to them. Okay. And this is, let us keep here 1 in the middle. Okay. Let us keep here in the 1 here in the middle. And of course, here secant in this way, let me change the color here to identify. Here, if you look at this one, this is the co-function tan. The co-function is called, or the reciprocal way also we can say, the reciprocal of tan is called, reciprocal of sine is cosecant, the reciprocal of cos is secant. In this way you can talk about this one. Okay, diagonally opposite, they are reciprocals to each other, right? And now again, let me lot of formulas we can bring from this one hexagon itself. Okay, now if you take this way, like this way, if you take this way and you multiply, let us see what happens. So tan theta into this, that is first and the third you are multiplying. Tan into cos theta, you will get the middle one. Okay, sin theta you will get. That is, you are multiplying 1 and 3, then you will be, of course, in order to remember this, again, they have to remember this ratio. Okay, it is just an activity only. Okay, to strengthen the concepts. Okay, so whenever you multiply 1 and 3, you will get the middle one. Here again, you see this one and this one, you multiply and see. So secant into cot. Cot is what? Cot theta. Let me write that. So this is 1 by cos into cos divided by sine. Cos will get cancelled. 1 by sine theta we will get, which is cosecant theta. So this is true in all the directions. Okay, throughout it is true. So this is one just activity which you can talk in your implement in your classes. And again, 90 minus theta, the complement angle also. Sine theta, the complement is here cos theta. Tan complement is cot here. Secant, the complement angle is cosecant. In that way also you can talk about this one. Okay, now if you take this one, now let me draw another hexagon. 1 second. So let me draw another hexagon. So how can we bring those identities? Okay, we can bring the identities as well here. So if I keep 1 here in the middle, okay, always what we have to write, tan we have to start with, sine theta we have to write here, cos theta we have to write, opposite to tan we have to write cot, all the c on one side. So cosecant is here, and here the rest, the remaining one, secant we will write. And now let us shade these, let us shade these alternate triangles. Okay, let us shade these alternate triangles. So if you shade this one and you take it clockwise this way you take. So sine square theta plus cos square theta value will be 1 here. Okay, and in anyway clock. Hello,
பசிக்குது
ma'am, kindly mute your.
போகுது இந்தம்மா நடந்துட்டே சாப்பிடுவேல.
Fine. So here again the square, we needed to square and add. That's what we have to give. Okay, sine square theta plus cos square theta will be is equal to 1. Here 1 square theta plus cot square theta is equal to cosecant square theta. You again take this in the clockwise direction, this symbol. So you will be getting tan square theta plus 1 square is equal to secant square theta. In this way you can do. And the same thing, you take the anti-clockwise, you will get again. And let me change the color here. Okay, if you take this anti-clockwise in this direction, if you take also, you will get some relation here. So cosecant square theta minus cot square theta is equal to 1, you will get. Okay, secant square theta minus 1.
Anti-clock subtraction operation.
Anti-clock will be subtraction, correct. Anti-clock will be subtraction.
Good idea, ma'am. Nice. This one.
Yeah, in this way, clockwise is addition, anti-clockwise is subtraction. So in that way, you give some techniques here after introducing all the concepts, not to introduce the concepts, but after introducing the concepts, we can explain to them or give some activity, or we can also ask them to prepare chart paper like this one. Okay, so if everybody does this one at least once, definitely they will be confident and thorough in all these concepts. So this is one technique. Okay, the next idea is as usual what we people are doing sometimes in our classes. This is just a the square shaped triangle, square shaped boxes. We can ask the children to cut this one and match the one with the equal formula. For example, you have to tell the children like a sine theta by tan theta. So what is the value? It is 1 by cos a secant. So secant should come here. In that way, they have to match it and fix the rectangle boxes again. Okay. So here maybe this one will help. Okay, this is the one I think. So this one they will match along with this one. These kind of small activities you can perform in the classrooms to bring the idea. So this is the answer for that. I have included this in so that when I'm sharing the PPT, it will be useful for you. And then you can give a lot of worksheets. Okay, lot of worksheets which will strengthen the activity. This is again a playway method only. Okay, they have to match with the correct answer, and they have to draw this one. So they will get a nice picture out of it. So this is one such activity. So a lot of activities, through activities you can bring this one. And I just want to show one of my class students record here. 1 second, which I did in my, so this is the record which I tried to prove the sine square theta plus cos square theta equal to 1. We are all doing this one in our classrooms. I just want to remind all of us. So this is the unit circle idea where the circle radius is taken as 5 units and 3 different triangles is taken, and ask them to find out the sine theta value opposite by hypotenuse, sine theta value adjacent by hypotenuse, ask them to square it and tell them to prove that the value is equal to 1. Sin square theta plus cos square theta is equal to 1. This is simply a record book work. We are maintaining one record, right? For that you can use this one. I think 4 or 5 activities we have to do every year. So we can make use of this idea in our classroom. Okay. And again, I would I'm just telling you all these things because we can the materials are available like this to tell. This is from our CBSE websites only. Lot of materials are available here. Lot of worksheets are available which we can make use of in our classrooms. So this is a formula set, okay, which I have taken from examination materials. I think materials from the CBSE websites, okay. And here they are telling one SOHCAHTOA method in order to remember the sign SOH. Sine means opposite by hypotenuse. Cos means adjacent by hypotenuse. Ka, TOA, TOA. So SOHCAHTOA. So in that way, some way of playway method, one word when we are introducing, they will remember that very easily. So these are all some idea. And again, we can ask them to make a table connecting one trigonometric ratio in terms of the other. And we are doing this as problems. We are testing them also in our class test and all. So let us give them as an activity to write this one as a table, let them submit. And again, we have a lot of worksheets available in the website. Make use of all these worksheets, which will strengthen these are all the worksheets which will strengthen the 30 value degree measurements. All these ideas will be developed. So a lot of worksheets are there, teachers here. Okay, 1 mark questions as well as 2 mark questions, lengthy 4 mark questions. There's around 25 pages is there. It includes the heights and distances questions as well. Okay, I will share this PDF, or probably you can also take from CBSE websites. So we can make use all these things in our classroom to strengthen activities. Now I would like all of you to do one activity, the clinometer. Let us all together do. Okay, I think you can take your materials if you have kept ready. Let us all together make once and make it a compulsory in every classroom. Let every children make this one as a project. Okay, and ask them to find the height of a tree in their own school or a school building, or maybe the pole where the Independence Day flag hoisting is happening. Any the height, any of the sort in your school, whatever is available. Let us tell them to find out the height as an activity. Okay, for that is my purpose. Please take your materials. Let us all together work out this one. I mean, do this one. Okay, I hope you have the cylindrical shaped one object, right? Or you can take your chart paper and make a cylindrical shaped one. Teachers, do you have the materials with you?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yeah, let us do one activity. So these are all the materials needed. One thread we need, one bead, or any small material which the thread should hang. Okay, a usual protractor. Have you all taken?
Yes, ma'am.
Yes, ma'am.
And then let us take a size, can be any size, okay, depending upon your hollow cylinder. It should match with that one, then only it will be beautiful. So I have taken here the size equal to my hollow cylinder, a sheet of paper I have taken. On one edge I have drawn a line, and exactly in the middle I have put a point here. Okay, I have marked a point here. Okay, let us all do it together. If you switch on the video, I will be able to see whether you people are doing it or not, isn't it?
Yeah. Okay. If you don't have materials, okay, no problem. Try some other time. So here in that middle portion only, we have to keep the protractor. You can also fold the papers and bring those things, but I didn't try that way. Okay, I am using protractor here, pointing in that middle point and marking all the angles here, 0, 10 up to 90 from left side, and similarly from the right side. Let us mark it using our pencil. Once you've done that, you can join those middle point and these points which you have marked now, which we are just making one small protractor only, enlarging it, that's it. You can also use the protractor. You can paste the protractor in that middle if you have one. Okay, that way also we can do. And let us mark the angles. If you have black sketch pen, then you can draw on this one instead of pencil. Will be beautiful. You can make it beautiful according to the availability of the materials. So I hope you have done that, and mark the angles on that. So the idea is, while we will also encourage the children to do such activities in our classrooms. So rather than working out problems every day, it will be monotonous. So if we shift slightly like this, the class will be interesting. Now we need a thread and attach a small bead, or even you can use a small pin or safety pin, something like that. One only we just need to make that thread in a straight while hanging that. Okay, some small item, anything you can use. Kavita ma'am and Jayalakshmi ma'am also doing, I believe. I'm not able to see you all. Yeah, yes. Okay. So once we did that, you can through that middle point, in that middle point, you can hang this thread and the bead, and at the same time you can use your gum and fix that cylinder also, that hollow cylinder. It's very simple. It's just a miniature of the clinometer which we are doing. Using this, this same principle is used in theodolite and big machines and all, in order to calculate the surveying especially. surveying and all, these are all the techniques they are using in those principle. Of course, principle is used in those big machines. Now, if you ask them to, so this is this is mine, which I have made. If I try to hang it, it is hanging like this. If you should move here and there when you are fixing it. It's like this. So when it is angle of depression, the right end 0, 1, 2, 0, 10, 20, that right hand corner, from there they have to measure it. If it's angle of elevation, from here, from the place where you are looking through this one, that way you have to do it. So let us measure at least one in your room where you are sitting, maybe your fan or your wall clock, something. Can you find the angle now?
I think we can use little heavy material, no? So that
Bead is not that heavy.
no, I'm telling you, we can use little heavy material so that we will get this string without any slack.
Yes, yes. A little bit more. Yeah, I need a little bit more. Yes. A heavy material we need. So that
paper clip is there, no? This
paper
one.
clip, that also fine. Yes.
This one.
Yes. Yes, yes. So that it will be straight. The thread has to be straight.
Whatever we are using in the school, the same protractor also we can use it.
Same protractor also we can fix instead of drawing this one. Yes.
But children, they can do this drawing.
No,
We
that's
can
an
give it as
activity.
one- Just we can give it as one task for children.
One
to
task,
do and
yes.
come.
One
That's the
task
idea.
we can give, yes.
And they will be able to do it much, very nicely.
Yeah.
They'll be very happy.
Their imagination will develop to
I
make
know, I
it
know.
beautify. So the next problem which you may face when you ask to find the angle of elevation, that thread may not stand exactly in the 80 degree, or it may not exactly in the 70 degree angle. So they will ask you how to find those angle values and all. Through that cylinder, you have to look up the object. The object you have to look through the cylinder. Then you find out where that thread is measuring. That is the angle of elevation or the angle of depression. So what we can, my suggestion is that you can also keep a table of values, trigonometric values like this one. When they are asking, this is 17 degrees, what I got, okay, you take the measurement from this one, from this table, you can tell them and you can ask them, you can help them to find the height of the school building or height of the tree or height of the pole, any that kind of things in your school premises. So hands-on experiences with the heights and distances they will get. So the main important point is the angle of depression. When they are coming, they will mark wrongly in the diagrams. So that and all will be made clear when you use these ideas. So where you have to mark the angle of depression in the diagrams. Okay, so, Ramya ma'am, I can see yours. Yes, nice. Yeah, who's showing me again? Yes, Jayalakshmi ma'am. Yes, nice.
Actually, I'm not getting cardboard, ma'am. So I just
Yeah, no problem. Try later also. Nice. So anyone else tried?
actually I got the big size, ma'am. So later I'll do it and send
Okay.
it.
Yes, no problem. Just try. Okay, no need to send and all. Just to try and help your children also to do that. Okay.
Sure.
Yeah. So just an activity only like this we can encourage. So these are all the topics coming under the ma'am. Jayalakshmi ma'am, you have to keep the horizontal one on top. Yeah, like that. Through that you have to see the object. Through that cylinder, hollow cylinder, you have to see the object. Then you see, you take your hand from the thread, let it hang freely. Yeah. Now you look at the object. You look at the object. Now you keep your finger on the thread and see where the thread is standing, which angle, at which angle it is standing. You look at the fan. Yes. Yes. Now keep your finger on the thread, fix it. Yeah. Now you measure. You can see the angle there. So angle of elevation you got from the place where you stand. Okay, so let us try in that way in our classrooms. So next is the angle of elevation depression. Through this activity itself, we can explain angle of elevation and the depression. And as I said earlier, the children tend to make mistake in marking the angles, especially the depression. When object is below the observer's eye level, it is the depression, and it is a downward, downwards the angle they have to mark. All these things through examples we have to make it clear. Okay, we already know all this one, and we are doing also. So here is one, just one idea which I want to show you all. See, this is the sign. As I said earlier, the vertical length is what is called as the sign, isn't it? See, that sign, vertical length, we are taking and marking it on the Cartesian plane. It will show the zigzag diagram like this. This is the graph of sign diagram. It will, the value will lie between +1 and -1 only, always. The value of sign is always between +1 and -1. That vertical distance is measured and it is plotting. Okay, so this is the usage of this sine function, cosine function, because all these sound waves, okay, and it is greatly used in radio waves, especially. All these are used in physics, learning physics and all. Simple harmonic motion, okay, such as simple pendulums, okay, the trajectory of satellites, okay, and rising and falling of the tides. There are all these kind of wavy nature of the sine and the cosine is a reason why we are giving so much importance to this trigonometric functions. So these are all you can explain in your classrooms, why this field is so important, why this topic is so important. All these things you can tell your children. Sorry. And then in under the category heights and distances, we already know the different types of problems we have, where problems involving one angle of elevation or one angle of depression, problems involving two angles of elevation or two angles of depression, and problems involving one angle of elevation and one angle of depression. So different from level 1, you increase the levels of the question, difficulty level of the questions, and then teach them. They will definitely understand. One main important point is that word problems, how to handle, the children don't know. So let us encourage the children to read the question 2-3 times. Okay, and then let them, as and when they read through the lines, they draw the diagrams. Once they get the diagram, they will be able to, definitely they will be able to do the problem. At that initial stage only, we have to help. So for that, a lot of problems, as I said earlier, we can give them. I just took one problem from each category. We all know even then. So these are all one example I have taken from each category. When one angle is given, one angle is mentioned in the question. Find the angle of elevation of the top of the tower 75√3 meters high from a point at a distance of 75 meters from the foot of the tower. So while drawing itself, let them mark which is the tower, which is the ground, which is the foot. So learning time, everything is possible. Examination point of view, maybe ABC is sufficient, but while doing the problem in their classwork, they have to, because later on revision while doing, by looking the diagram itself, they will understand clearly. So let us encourage them to write all these things and help them to find the value of the theta here. And here only, as I said earlier, students may tend to draw the angle here. They may sometimes measure draw the angle here, angle of depression. So we have to tell them this is not the way. So eyesight, this is the eyesight and where the object is taken. So here the object, so that angle is angle of depression. So strengthen that idea through the examples. And these are all, they will not make mistake, but we just have to encourage them to read the question 2-3 times and allow them to work out. These are involved 2 triangles, 2 right triangles are involved. And maybe in questions like, for example, mountain is given and from 2 milestones that is observed. Okay, here, for example, this kind of question, and one angle is 30 degree, another angle is 60. They don't know where to mark the 60 and where to mark the 30 degree angle. So logically we needed to tell them, okay, the one which is nearest to the mountain will be more the 60 degree, and this one will be the least. In that way we have to tell them. This mistake children always make. So let us give more example of that kind and help the children. Okay, these are just a simple examples you may be already doing in your classrooms. I don't have to teach you the problems. I'm just giving you some examples where here 2 angles of depression we have. This is the question of that type where 2 angles of depression. Okay, so this is to find the width of the river and the height of the second temple, CD, they have to find out. So they will take 2 right triangles. From one of the right triangle, they will get one of the value, and that may be used in the second right triangle to find out the unknown. So different problems, we need to use different trigonometric ratios depending upon the situation. So there is no common rule and all. So this is one question where higher order thinking level question, the cloud question, which is already there in the textbook. This is a little higher order because the children should know that law of reflection also in this one, height of the object is equal to depth of the reflection of the object. This is something we needed to tell. The children may not know that. So unless otherwise they are good in their science topics. So we needed to tell that a previous knowledge is needed here. Okay. And then angle of elevation is there, angle of depression is there. If they are unlike, they don't mark these A, B, C, D, E, F for these names and all clearly. If they don't mark and start the idea, they will make mistake in this one. So let us encourage the unknown value to mark it as H, X, all these ideas they can use and bring that one. Okay, so this is a higher order level. So once this, after giving all the level 1 question, let us touch upon these kind of questions in the examination point of view. And I think that will help the children a lot.